Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound is 2-methyl, 1,4-bis, chloromethyl, benzene, a benzene ring with a methyl group and 2 CH2Cl groups. The 2 CH2Cl groups are at positions 1 and 4 relative to each other, with a methyl group at position 2. Let us first understand the key concept here. The Wurtz reaction involves treatment of alkyl or benzyl halides with sodium metal in dry ether to form C-to-C bonds via radical or carbanion intermediates. When two different CH2Cl groups are present, either on the same molecule or between two molecules, both intermolecular and intramolecular couplings can occur. Moving on to the next step. Intramolecular Wurtz reaction. The two CH2Cl groups on the same molecule couple with each other, forming a 5-membered ring fused to the benzene ring. This gives the product in option C, an indene-like bicyclic system, actually a 1,3-dehydroisobenzofuran analog but all carbon. However, looking at option C more carefully, it shows a fluorine-like structure, suggesting two molecules intramolecular products are shown fused, but option C represents the intramolecular product. Intermolecular Wurtz reaction. Two different molecules couple via their CH2Cl groups. Since the molecule has two CH2Cl groups, one at position 1, one at position 4, and a methyl at position 2, intermolecular coupling of one CH2Cl from one molecule with one CH2Cl from another, and then the remaining two CH2Cl groups coupling, gives a macrocyclic or bibenzyl type product. This leads to options A and B, which differ in the relative orientation, head-to-head versus head-to-tail, of the two monomers coupling together. And for the final step. In intermolecular Wurtz coupling of an unsymmetrical bis, chloromethyl, compound, the two benzene units can couple into orientations parallel, same direction, giving symmetric product A, or antiparallel, opposite direction, giving product B, with different CH3 positions. Both orientations are possible since the molecule is not symmetric, it has CH3 at position 2, making positions 1 and 4 non-equivalent. While intramolecular coupling, option C, is possible in principle, Wurtz reactions with sodium metal in intermolecular conditions predominantly give intermolecular products, especially for 1,4-bis chloromethyl systems where intramolecular ring closure would require formation of a strained small ring or is geometrically less favorable compared to intermolecular coupling. The question asks for the products of the Wurtz reaction, and the answer includes both A and B, because the intermolecular coupling of the unsymmetric starting material can give to regioisomeric dimeric products depending on the orientation of coupling. Therefore, the correct answer is D. Therefore, the correct answer is option D.